We have been assigned to solve water supply problem at the residential blocks of College Rafflesia, Unimas, and to supervise the water problem supply at Block O. Block O is a 4-story apartment block. Each floor at Block O was labeled as ground floor, first floor, second floor and third floor. Each floor has different elevation and it was stated in the calculation. Each floor consists of 8 houses and each house have 2 toilet area. When the water demand is high, the water pressure in the pipe may reduce and might cause smaller flow rate at higher elevation. As the water flow through the pipe at higher elevation, increase in head loss due to friction along the pipe cause the volume flow rate to reduce. This cause the water in the pipe have insufficient flow rate to reach the top floor. Low pressure in the water cause the water in the piping system is not enough to reach the top floor of the apartment. The major head losses in the piping system also cause the reduction of the water flow rate. The current water supply problem at College Rafflesia is all rooms on the 3rd floor is unoccupied because the water supply does not reach the wet area on the 3rd floor's houses. This may due to higher elevation at the 3rd floor that cause reduction in pressure and the major head losses along the pipe. Each house has a single vertical pipe where the fluid is flowing upward and into the water tank located at the toilet. 1. To determine the water supply problem at the residential blocks. 2. To investigate the suitable type of pump. 3. To analyze the cavitation in the system. Problem statement. 1. What is the water supply problem at the residential blocks? 2. What are the pumps suitable to be installed? 3. Are the cavitation occur in the system? In order to take the water volume and volume flow rate reading, we choose the peak time at 7.05 a.m. to take the reading. The peak time help us to measure the maximum water usage and volume flow rate at each house. The water volume reading is taken at the same time at each floor from the water flowmeter. The initial water usage reading was recorded at 7.05 a.m. and the final reading was taken at 4.05 p.m. on the same day. The duration was 9 hours. On the other hand, we use a 5 gallons bucket to measure the volume flow rate at each floor. We enter a house at each floor to fill up the bucket and take the time taken for water to fully fill up the bucket. The volume flow rate measured was only limited to the water tap in the toilet only. Assumptions. 1. The wet area in a house is limited to the toilets only. 2. All house on ground, 1st and 2nd floor are fully occupied with 10 students per house. 3. All minor losses along the piping system are negligible. 4. Only galvanized iron pipe is used in the piping system. 5. Room temperature is 27 degrees Celsius and water density is 1000 kg/m3. In the result, Table 2 shows the total volume of the water that being used within the time duration. Table 3 shows the flow rate of the water at point just before the flow meter. The total flow rate for left side is 75.39 times 10 power of -6 meter cube per second. The total velocity for left side is 0.2645 meter per second. The total flow rate for right side is 14.51 times 10 power of -6 meter cube per second. The total velocity for right side is 0.05092 meter per second. Table 4 shows the time taken and exit rates to reach 5 gallon of water in each floor, while Table 5 shows the total time needed to fill up the 2 tanks in each house, provided with assumptions. Calculation. Table 6 shows the total head loss for each block side. The total head loss for left side is 0.5024 meter, while the total head loss for right side. At the left side, NPSHR equals 2 meter, H equals 14 meter. The number of pump is 1 and according to the NSP the centrifugal pump need to be used. At the right side, the NPSHR equals 2 meter, H equals 14 meter. The number of pump is 1 and the according to NSP the suitable pump is centrifugal pump. Discussion. The water supply problem can be solved by installing pumping system at each block with suitable number of pump. It is important to calculate its NPSHR and NPSHR. NSFL is the function of pumping system whereas NPSHR is the function of the pump and must provided by the pump manufacturer. This NPSHR must greater than NPSHR to avoid cavitation which normally occur when the pressure in the pump inlet drop below the vapor pressure of the liquid. We choose the smallest diameter because it have low cost of construction due to relatively little material is required since the smallest pump requires less power compared to largest diameter pump. For both side, only one centrifugal pump is enough in order to make the water to reach the third floor. Conclusion. Objective of this project is achieved. The pumping system been installed at each block by choosing Bell and Gossett pump. The result showed the value of NPSHR greater than NPSHR which mean the cavitation been avoided in this system during the operation. We can conclude in this residential block for both side, there was only one centrifugal pump required to make the water being pumped and flow up until third level.